Foundations of Amateur Radio. At a recent local HAMfest, we set up a table to measure second and third harmonic emissions from any handheld radio that came our way. The process was fun and we learnt lots, and in due course we plan to publish a report on our findings. When we received a handheld, we would disconnect the antenna and replace it with a short length of coax and connect it to a spectrum analyzer. We would then trigger the push-to-talk or PTT button and measure several things. We'd record the actual frequency and how many watts that the transmitter was producing, and then record the power level in dBm for the base frequency, double that frequency, and triple that frequency. In other words, we'd record the base, second, and third harmonics. This resulted in a list of numbers. Frequency and power in watts are obvious, but the 3 dBm numbers caused confusion for many visitors. The most perplexing appeared to be that we were producing negative dBm numbers, and truth be told, some positive ones as well. We'll get to those in our report. How can you have negative power, you ask? As I've discussed before, a negative dBm number isn't a negative value of power. It's a fraction. So, minus 30 dBm represents 0.000001 watts. And you'd have to admit that minus 30 dBm rolls off the tongue just a little easier. What we measured and logged was the overall transmitter output and at specific frequencies. As I've discussed previously, if you transmit using any transceiver, you'll produce power at the intended frequency, but there will also be unintended or unwanted transmissions, known as spurious emissions. The International Telecommunications Union, or ITU, has standards for such emissions. In Australia, the regulator, the ACMA, uses the ITU standard for radio amateurs. But I should point out that this might not be the case where you are. It's entirely possible, and given human diversity, probable even, that there are places where there are more stringent requirements, so bear that in mind. I'll state the standard and then explain. For frequencies greater than 30 MHz, the spurious emission must not exceed the lesser of 43 plus 10 times the logarithmic power, or 70 dB. That might sound like gobbledygook, so let's explore. First thing to notice is that this is for transmissions where the transmitter is tuned to a frequency greater than 30 MHz. There's a separate rule for frequencies less than 30 MHz. And the ITU also specifies a range of different limits for special purpose transmitters like broadcast radio and television, space services and others. Second thing is that the spurious emissions are calculated based on total mean output power. This means that your spurious emissions are considered in relation to how much power you're using to transmit. And it implies that for some transmitters you can be in compliance at one power level but not at another, so keep that in mind. The phrase the lesser of means that from a compliance perspective there's a point at which power levels no longer determine how much attenuation of spurious emissions is required. You can calculate that point. It's where our formula hits 70 dB, and that is at 500 watts. In other words, to meet the ITU standard, if you're transmitting with less than 500 watts, you're subject to the formula, and if you're transmitting with more than 500 watts, you're required to meet the 70 dB standard. It means that, at least in Australia, spurious emissions for amateurs are dependent on transmitter power because the maximum permitted power is currently 400 watts for an amateur holding a so-called advanced license. Now, I'll also point out explicitly that the emission standards that the ITU specifies are for generic radio equipment, which includes amateur radio, but also includes anything else with a transmitter. One thing to mention is that spurious emissions aren't limited to the second and third harmonics that we measured. In fact, they're not even limited to harmonics. If you're using a particular mode, then anything that's transmitted outside the bandwidth of that mode is considered a spurious emission, and there are standards for that as well. As an aside, it was interesting to me that in many cases amateur radio is treated separately from other radio services. But the ITU considers our community just one of several spectrum users, and it's good to remember that the entire universe is playing in the same sandbox, even if only some of it is regulated by the ITU and your local regulator. So let's imagine that you have a handheld radio that has a total mean power output of 5 watts. When you calculate using the formula, you end up at 50 dB attenuation. In other words, the spurious emissions may not exceed minus 13 dBm. So if your radio measures minus 20 dBm on the second harmonic, it's compliant for that harmonic. But if it measures minus 10 dBm, it's not. I should also point out that this is for each spurious emission. About half the radios we tested had a second harmonic that was worse than the third harmonic. So what does this mean for your radio? I'd recommend that you start reading and measuring. You'll need to measure the total mean power and the signal strength at the base frequency and the second and third harmonic. I will mention that surprises might happen. For example, the Yaesu FT857D radio I use every week to host a net appears to be transmitting with a power level that doesn't match its setting. At 5 watts, it's only transmitting just over 2 watts into the antenna. But at the 10 watt setting, it's pretty much 10 watts. You also don't need a fancy tool like we were using. All these measurements are relative to each other, and you could even use a $20 RTL SDR USB dongle. But before you start transmitting into its antenna port, make sure that you have enough attenuation connected between the transmitter and your dongle. Otherwise, you'll quickly discover the escape velocity of the magic smoke inside. I'm Ono, Victor Kilo 6, Foxtrot Lima, Alpha Bravo.